Hello friends, here we find the ground state energy of helium by using variation method. The helium atom consists of 2 electrons and a nucleus, and the nucleus with 2 protons and 2 neutrons. Using variation method, we can find the ground state energy. So we can find the expectation value of Hamiltonian. Hamiltonian for helium atom contain 2 independent hydrogenic Hamiltonians. Hydrogenic Hamiltonian means it consists of 1 electron and 1 proton. That way we have 2 electron and 2 proton. So consider it as a 2 independent hydrogenic Hamiltonian. This is the Hamiltonian equation. It is equal to minus h cut square by 2m del 1 square minus z e square by r1 plus minus h cut square by 2m del 2 square minus z e square by r2 plus e square by r12. And another electron-electron interaction form the wave function taken as a product of two normalized hydrogenic ground state wave function. The term E square by R12 taken as the electron-electron repulsion term. The exact solution of two hydrogenic Hamiltonians is just the product of two normalized hydrogenic ground state wave function. Here, the trial wave function taken as phi is equal to phi1 r1 into phi2 r2. Then the value of phi is equal to z cube divided by pi a cube e raised to minus z by a square into r1 plus r0. Because an electron can attract with the nucleus, but there is second electron present in the helium atom. Due to that electron, there is some difference in the attraction between the second electron and the nucleus. Due to the screening of the attraction of any one electron to the nucleus by the other electron, there is an effect will happen. The nucleus charge is not exactly 2e but expected to be lesser. This is due to the screening of electron. It is called the Coulomb screening. This makes an effective reduction. That is Z tends to Z bar, which is taken as a variational parameter. So we define phi with Z tends to Z prime. This is the trial function in this problem. And the Hamiltonian H is given by minus h cut square by 2m del 1 square minus Z prime e square by r1 plus minus h cut square del 2 square by 2m minus Z prime e square by r2 plus Z prime minus Z e square into 1 by r1 plus 1 by r2 plus e square by r12. And the equation 10.24 gives the expectation value of h. Then evaluate each terms in the expectation value. First, the value of first and second terms on the right are equal and each is minus z prime square wh, where wh is equal to me raised to 4 divided by 2h cut square. Then integrate the term phi1 e square by r1 phi1 which gives z prime cube e square by pi a naught cube 4 pi into 1 divided by 2 z prime divided by a square the whole square. Here we use the standard integral form. Then we get 2 z prime wh. Then phi2 a square by r2 phi2 is equal to 2 z prime wh. Then phi1 phi2 is square by r1 to phi1 phi2 is equal to 5 by 4 z prime wh. And putting all these terms together in equation 10.24, we get expectation value of h is equal to minus 2 z prime square wh plus 4 into z prime minus z into z prime wh plus 5 by 4 z prime wh. Then minimizing with respect to z prime, that is dou e by dou z prime is equal to 0. Then 0 is equal to minus 4 z prime wh plus 8 z prime wh minus 4 z wh plus 5 by 4 wh. From this equation we get z prime is equal to z minus 5 by 16. With this value of z prime, the equation 10.28 gives E is equal to minus 2 into Z minus 5 by 16 the whole square into WH. Then substitution of WH is equal to 13.6